All right. Hello, everyone, and welcome to another webinar. My name is Aaron Essery, Assistant Extension Specialist for Viticulture and Enology here at OSU. Today, I have almost Dr. Amanda Fleming here to present about non-Saccharomyces yeast. So without further ado, Amanda, the floor is yours.
Okay, thanks, Aaron, for inviting me to speak today. Um, so I am in my last semester of my PhD, and I have found the more I learn about wine and grapes, the more I realize I do not know. But I'm going to share with you some of what I do know, as we know that wine is a fascinating subject. So I'm here at the Food Science Department at the University of Arkansas in Dr. Renee Threlfall's lab, and I do have some of my lab mates online too as well today. So I'm glad they could join and glad that all the Oklahoma folks could be here who are in the industry. So we're going to talk about non-Saccharomyces yeast today and its application. But first of all, we'll do just a very brief overview of wine yeast, the types of non-sac yeast that are around on the market, and how to use them successfully in wine production, where you can purchase these and roughly what the prices are going to be for the different non-sac yeasts, and then questions and comments at the end. Now, if you ask me a question and I don't have the answer, I'm happy to find the answer for you, so I can either send it to your email or send the answer to Aaron and he can forward it to you. It's all up to you. Um, so some of my research has to do with non-Saccharomyces yeasts, and that's why Aaron asked me to speak today. So just giving a traditional overview of or an overview of traditional yeast in winemaking. Usually people do what's called a controlled inoculation with Saccharomyces yeast to ensure a successful fermentation. So there's kind of this dichotomy between like your controlled inoculation with Saccharomyces and then your native or wild fermentations, which can be a little risky if you don't know what's coming in on your grapes. I have worked with winemakers. So I used to work in the commercial industry in California for several years, and I worked with winemakers who lots who used controlled inoculation with Saccharomyces cerevisiae, but others who would bring in their grapes and just let the fermentation start on its own. So they were bringing in microflora from the grapes, the leaves, the soil in the vineyard, and definitely a little bit risky, but a lot of these winemakers who are a little more what we thought of as loosey goosey, a little less conservative and a little less risk averse would say, well, no risk, no reward. So at a lot of times these wild wines, ferment wines that they would make would have very complex flavors and aromas compared to the Saccharomyces fermented wines only. So I know winemakers have been very interested in the use of non-Saccharomyces yeast in wine production, but they want to use it in a way that's going to be more controlled and with very few risks and all the benefit instead. Um, so with your controlled inoculation with Saccharomyces, you're going to finish out your fermentation in 2 to 3 weeks. A lot of us know this already. And then with your wild and native fermentation, traditionally before these non-sac yeasts were on the market, it could take three or more weeks to finish out a fermentation, and sometimes maybe the fermentation would get stuck. Lots of times, the fermentation with these native yeasts, the native yeast would die out around 4% ethanol. So then you have your Saccharomyces taking over, probably just Saccharomyces that's already in the winery, or just in your home area where you're doing your fermentation. Um, Non-Saccharomyces yeast in general have about 20 genera and over 700 species. They're found in the vineyard. The non-Saccharomyces yeasts are an important part of the early stages of fermentation because they're non or mildly fermentative at most. So 3 to 5% ethanol production is what they can do. Some of them don't even produce ethanol at all. Um, we're really interested in these non-Saccharomyces yeasts because they contain some unique enzymes for flavor and mouthfeel enhancement that Saccharomyces yeast just don't have. And they can also contribute microbiological control for grapes and for juice by consuming dissolved oxygen, consuming other substrates that spoilage yeast might want. So that's good. They can dominate and take over without actually hurting your grape must or your juice. But not all non-sac yeast have a positive impact. We know that, like with Hansinia spora yeast, Callicera, um, or not Callicera, Apicia, and Brettanomyces. Those guys, Zygosaccharomyces, of course, we don't want those spoilage yeast in our ferments and in our final wines. So here comes the advent of commercial non-sac yeast strains. So I think there's probably been, just reviewing the literature in the last few years of my research, it's in the last 20 years, non-sac yeast have become more popular, and they're more and more on the market every year by different manufacturers, which I'll talk about a little bit later. So the most common commercial non-sac yeast strains you'll find on the market are Lachantia thermotolerance, which is what I have done some of my master's and PhD work on. So I do know the most about thermotolerance. There's also Torulaspora delbrueckii, Metschnikawia pulcherrima, and Metschnikawia fructicola. Most of these yeasts, like as I mentioned before, are not going to be able to complete alcoholic fermentation. So they do need to be used in sequential inoculation with Saccharomyces cerevisiae to complete a successful fermentation, all the sugars consumed. Some of these yeasts are known for modulating acidity, like Lachantia thermotolerance, and increasing acidity. Some have antimicrobial or antioxidative qualities, and others enhance flavor, aromas, and mouthfeel. So it's really what you're looking for and how you want to tailor the style of your wines. So moving first to Lachantia thermotolerance, this yeast acts as a natural means of acidification for low acid wines. A lot of winemakers will use this yeast in low acid red grapes, but it can also be used in white grapes grown in warm regions. So instead of having to dump a whole bunch of tartaric acid into your grape must or your juice, you can use Lachantia thermotolerance instead to lower the pH and increase the final titratable acidity. We know that having a good acid balance will add freshness and complexity to the final wine product. That's really important. The specific acid that Lachantia is generating is lactic acid. So it's actually converting glucose and fructose into lactic acid and bypassing that ethanol production pathway. So sometimes people, when they use Lachantia, will see a slight decrease in the final ethanol of their wine compared to a wine that's made with Saccharomyces cerevisiae only. In my research, I didn't really see a significant reduction in ethanol compared to the control, but it has been reported in some of the literature. This yeast is added directly to the grape must prior to Saccharomyces cerevisiae. Then Saccharomyces will be added to the grape must 24 to 72 hours after Lachantia thermotolerance has been added. So the longer the interval between thermotolerance and cerevisiae, the more lactic acid will be produced. So it's really like, are you looking for a major acidity boost? Did your pH come in really high? Was your acid really low? If so, maybe you wait 72 hours after Lachantia thermotolerance inoculation to add your Saccharomyces cerevisiae. So the most obvious benefits of this yeast is that it's going to lower the pH by, anywhere from 0.2 to 0.3 units is what I've seen in my research. Higher lactic acid, anywhere from 3 grams to 6 grams per liter. Higher titratable acidity. I had some wines with titratable acidity upwards of 10 grams per liter, and that's really high. So a lot of times people will use wines made from Lachantia thermotolerance as a blending wine to blend in some more freshness and acidity to low acid wines. Another benefit is that this yeast can help to maintain lower acetic acid, just assuming that you use proper sanitation, of course, in the winery. Having a lower pH is always going to help with microbial control, and will also help with improved and sustained color in your reds and also, in your whites. A note of caution with this higher lactic acid production, I found in my own research, and then it's established in the literature too, that malolactic fermentation, if you try to inoculate for MLF with the Enococcus eni bacteria, MLF can be inhibited if the lactic acid is greater than around 4 grams per liter. So too much lactic acid is toxic to the Enococcus eni bacteria. So what I found to be most successful is to actually do a co-inoculation. So you would add your Lachantia thermotolerance, maybe 48 hours later, add your Saccharomyces cerevisiae to your grape must, and then 24 hours later, do a co-inoculation with a malolactic bacteria. And then lots of times that MLF will complete. So in my PhD research, I did that, and the malic acid was consumed entirely by the end by both the Lachantia thermotolerance and the malolactic or the Enococcus eni bacteria. But some when to use, it's varietals that struggle with low acidity. So for us here in the Mid-South and the Southeast, I'm thinking of the reds like, sometimes Chamberson does. I don't know if Cynthiana or Norton ever has issues. I know that one can be kind of a weird one with acid and pH. We have Enchantment here in Arkansas. That's a University of Arkansas red wine grape, and that can have high pH as well. When you're coming from a warm, growing climate where the pH of your wines or even your grapes coming in are exceeding 3.7, you might want to think about using this yeast. Again, if you end up with wines with a pH greater than 3.7, you could have problematic color, especially with these hybrid grapes that are deficient in phenolics and tannins. So they struggle with color retention. I know Cynthiana is one of those. And like I said, I think that Lachantia thermotolerance is also a great blending component for acid management in your overall, in a wine that has lower acidity and higher pH. So this figure that's on the right is from a publication of mine from my master's, and I was looking at the control is Saccharomyces cerevisiae, and I was looking at using Lachantia thermotolerance with and without malolactic fermentation. So I have 4 treatments here: the control, and then the Saccharomyces cerevisiae control with malolactic fermentation added, so with and without, and then Lachantia thermotolerance with and without malolactic fermentation. And with the Lachantia thermotolerance treatment, Saccharomyces cerevisiae was added 48 hours after the initial thermotolerance inoculation. But we found that with the Lachantia thermotolerance treatments, regardless of MLF activity or not, the wines were scored much higher by consumers in a sensory study for color. So not, mouthfeel and flavor were a little bit on the lower end. The wines were quite tart. So I think overall people were really favored the Saccharomyces, the control for flavor and mouthfeel. But it is notable to see that color was really impacted in a positive way by the Lachantia thermotolerance. And again, would be used as a great blending component. Moving on to the next yeast is Torulaspora delbrueckii. This is a really interesting non-sac yeast because it's really great for producing or enhancing mouthfeel and aromatic compounds in the final wines. So it's going to create more of a roundness and volume through some of the polyols. It's types of alcohols that are produced during fermentation. The aromatic compounds that are going to be produced are mostly those thiols, so think tropical, terpenes, so maybe floral. Another added benefit is lower volatile acidity production because the delbrueckii consumes some of the glucose and fructose in the grape must or the juice, and thereby alleviating some of that osmotic stress on the Saccharomyces when it's eventually added to the grape must. Saccharomyces yeast should be added sequentially after delbrueckii, after up to 4 degrees drop in Brix during your fermentation. So a lot of people, there's been research on people using this yeast for high sugar grapes, especially like late harvest and ice wine production. So it's really helping control that acetic acid. level during those fermentations. There's been a lot of research out of Brock University. They do ice wine with Vidal grapes, and they use a product by Lallemand. It's Delbrueckii, but it's called Biodiva. And you can see on the figure on the right that Biodiva at both 25 grams per hectoliter and 50 grams per hectoliter significantly reduced acetic acid production during fermentation compared to the Saccharomyces control. And this was working with an ice wine production. And then also it's going to really enhance esters, the styles of terpenes, and create a more complex mouthfeel for all different wine types. So in the other figure on the left, the Biodiva is kind of that burgundy bar, and the Saccharomyces is the blue bar. And you can see that for olfaction attributes and mouthfeel attributes, that Biodiva outcompetes most of the attributes. So, higher in red fruit aromas for Delbrueckii, mouthfeel, sweetness, smoothness, aromatic intensity, and overall quality compared to the control. And then Mechnikowie pulcherrima is another popular non-sac yeast on the market. There are kind of two types that winemakers have a choice to look at and use. The first type is one that's more focused on creating really interesting thiols and terpenes during fermentation. So this particular strain of Mechnikowie produces enzymes that cleave aroma precursors to release those aroma precursors during fermentation, and they'll show up in the final wine. And it's really notable for enhancing aromas of whites and rosé wines. It can withstand up to 3% ethanol, and it's, of course, used in mixed inoculation with Saccharomyces cerevisiae. So Saccharomyces will be added 24 hours after Mechnikowie. It's really going to help elevate the tropical fruits, floral, spice aromas in the wines, and also increase the manoprotein content in wine, which is going to improve the overall mouthfeel of the final product. So this strain of pulcherrima has a particular enzyme called beta lyase, which you can see on the figure on the left, this line graph. And beta lyase is responsible for helping cleave the bound aroma precursors in juice and must to release those thiols and terpene volatile aromas. And the green line shows that's the M. pulcherrima flavia by Lallemand Enology. You can see that beta lyase activity is pretty high for the first 100 hours of fermentation, whereas with the Saccharomyces cerevisiae, that enzyme activity drops after 20 hours significantly. And then looking at these spider graphs kind of on the right here, you can see that Flavia and sequential inoculation with the Saccharomyces cerevisiae produced wines with more floral, fresh fruit, and citrus aromas compared to the control, and then produced wines with a sweeter, more balanced, and higher volume compared to the control. So a lot of benefits with these non-sac for improving mouthfeel, for improving aroma and flavor, more complex kind of overall attributes than you would find using just Saccharomyces yeast alone. And then the type 2 Mechnikowie is a strain that offers bioprotection for whites and rosé grapes during pre-fermentation stage, during stabulation, which I'll explain that in a minute. So this is done at low temperatures, but the Mechnikowie pulcherrima is going to protect the must or the juice against oxidation. It actually consumes dissolved oxygen, and it limits browning by not only consuming oxygen, but also copper ions. And then it uses oxygen as a growth factor. So it creates more biomass and really dominates the spoilage microflora that would produce acetic acid in your juice or your must. Like some of the other non-sac yeast, it has low fermentative ability, so you don't have to worry much about ethanol production. The specific acid that M. pulcherrima is producing that is detrimental to the spoilage microflora is pulcherrimic acid. So what that does, for the people who are kind of interested in like the microbiological chemistry pathways, it's the acid binds to the ferric ion and then basically starves out the pathogens of that essential iron that's needed for their survival. So you're going to add this to your pressed juice in the cold settling stage if you're doing stabulation. I'll again explain that in a second. And then once your juice is racked to the fermentation vessel and ready to go for fermentation, then you would add your Saccharomyces strain. Um, so stabulation, I've never done this. I think it sounds really cool though, as a method. It's used a lot in France apparently for rosé production, but it's a process where either rosés or white juice is kept at low pre-fermentation temperatures. So think like 30 degrees and kept on the solids to really bring out the mouthfeel and those thiols and esters prior to the beginning of fermentation. So you want to get all the good stuff out without the risk of a fermentation happening. So that's why this strain of Pulcherima can be used. You can also use this in general if you just have some browning and oxidation concerns with the grapes that you're bringing in. It's a great option for if you're transporting juice. So I've known wineries that are transporting juice from one state to the other, and they'll use this yeast. They'll add it to the juice prior to transportation. And of course, you don't want to, transport in a hot truck, but you want to keep your temperatures low. But this will really help reduce the yeast, the bad yeast population. And then because you're going to be using this, you can really reduce significantly your SO2 additions. I know some winemakers don't want to use a lot of SO2. So this is a nice bio tool to use in lieu of the SO2 additions. So you can see in this figure down here, this was looking at a cold stabulation study where the yeast population in the initial must was contained about 30% Hansenia spora, which can create ethyl acetate, and then 68% other yeast. But then with the addition of the M. pulcherima, which is Initia from Lallemand, that M. pulcherima really took over during the 5 days of cold stabulations. So like 97% of the yeast were found to be comprised of the Initia, and less than 5% was made of the Hansenia spora. Then compared to the control, so no use of Initia or M. pulcherima, you had quite high Hansenia spora population that was generated during the course of stabulation. Another Metchnikowiya yeast species is Fructicola, and I've actually been able to use this in the commercial wine setting before. It is another bioprotectant against native microflora that are going to produce your acetic acid, your ethyl acetate, and even helps with botrytis cinerea infections. So it's, again, you can reduce the use of your SO2 during pre-fermentation. You would add this directly to your must or your juice prior to transporting, or you can add it during a cold soak. So this is a picture of some Cabernet Franc that I brought in. This was in Arkansas. We actually got the fruit out of Washington, so we transported it in a refrigerated truck, about 2-3 day transport. The fruit came in beautiful, and I wanted to do a cold soak on it for 5 days and reduce the amount. I don't think I used any SO2 on this. I had a control too where I used SO2 and didn't use any Fructicola, but I was able to cold soak these grapes with the Fructicola added. I didn't have any issues with microbial spoilage. I wanted to get good color extraction during the cold soak before we started our actual alcoholic fermentation. And I kept this cold soaking bin in a cold warehouse at about 52 degrees. And I think that's kind of the Metchnikowiya Fructicola likes cold temperatures, so around 35 to 52 is where it works really well. And the nice thing, it has very weak fermenting power. You don't have to worry about ethanol production. Again, you're going to use this in mixed inoculation with Saccharomyces. When I was ready to end that cold soak and start my fermentation, that's when I added my Saccharomyces cerevisiae yeast. So you can use this on whites, rosés, red musts, so really all kinds whatever grapes you have coming in that you want to use it on. It also can help preserve varietal aromas because you're not producing acetic acid, ethyl acetate's not being produced by microbial spoilage organisms, and it is a safer extraction of anthocyanins during cold soak. Um, and this fructicola, I think that the only fructicola that I've found on the market is through Lallemand, the Gaia that they have, but I'll have a list of slides with who produces what and where you can get it. There's also some non-Saccharomyces yeast blends on the market, which I thought was these are pretty cool, I think. I haven't used them, but there's a line called Zymaflor, and they have what's called the Zymaflor Aegide. It's a blend of Delbrueckii and Pulcherima for bioprotection of grapes and juice. So it's another SO2 reduction strategy. And so this yeast blend is going to colonize that harmful microflora. So there's not going to be any sort of negative aromas that are produced. There's not going to be any fermentation activity with this yeast blend. So again, you'll have to do a sequential inoculation with Cerevisiae, and it can be used on all different types of grapes and styles. I have heard of people who use the Pulcherima or this yeast blend on their harvest equipment to control microflora, like during your harvest picking. So they'll put it on their in their bins. They'll put it like on their machine harvester. I haven't actually done it myself, but they'll just like mix up a batch of it, kind of spray it on their equipment, and that will really help control the spoilage microbes that are coming in off the vineyard. Again, though, you do need to keep the juice in the grapes at a lower temperature to help facilitate these non-sac yeasts to do the best job that they can with keeping microbes at bay. Another yeast blend is sold by C.H.R. Hansen. It's called Melody. So this actually has 60% Cerevisiae in it, and then 20/20 of Delbrueckii and thermotolerance. So because it has the Cerevisiae dominant in the blend, it actually can complete a fermentation up to 15% ethanol. So really, there's no need to do a sequential inoculation with Saccharomyces cerevisiae if you do use this yeast. It's a low SO2 and VA producing yeast. But its main thing is it's going to enhance the fruity flavors in your reds and whites through thiol and ester production. I'll talk about temperature ranges for some of these yeasts and SO2 additions, but typically non-sac can be very temperature sensitive and SO2 sensitive. But this blend, this Melody blend, because it has Saccharomyces cerevisiae in it, can really ferment more at that standard temperature fermenting range of 50 to 90 degrees. And then you can easily add your 30 ppm at crushing if you do use this yeast. So going off of that, I just wanted to mention some of the important sulfur dioxide rehydration and nutrient strategies if you do decide to use non-Saccharomyces in your fermentations. You always want to read the manufacturer's directions, the tech sheets, when using these non-sac yeast. The tech sheets are very, very helpful. And if you are confused, then you can call your rep and they will walk you through it. Or you can ask Aaron, or you can shoot an email to me. Many of these non-sac yeast are SO2 sensitive, as in they can't handle more than 15 parts per million of free or total SO2. I think it's usually free SO2, but it'll specify on the tech sheet. Some of them are rehydrated differently than Saccharomyces, so you don't have to use GoFirm, but you also have to pay attention to the rehydration temperatures. I know, for instance, that Lactantia thermotolerance doesn't like to get warmer than like 85 degrees Fahrenheit in its rehydration water, so less tolerant to warm temperatures compared to Sac. Some of the yeast apparently have juice turbidity requirements, so you don't want the juice to be too clarified. The yeast needs some nutrients to hold on to in the juice and the juice to start working properly. And again, always remember that these yeast, if they do have some fermenting capabilities, will die out around 5% ethanol. You also want to make sure that your yan is appropriate in your incoming grapes. I know in Arkansas, we don't really have issues with low yan. I don't know what it's like for Oklahoma, but you want to ensure adequate yan levels before adding the non-sac yeast strains. So usually it's over 100 milligram per liter for red fermentations and 150 milligram per liter for white wine fermentations. So looking at some of the commercial sources of these yeast strains, there's Alalamond, produces a lot of non-sac yeast. The supplier is Scott Laboratories. Their level 2 yeast is their line of non-sac yeast. So you've got the Lactea, which is the L-thermal tolerant strain, Flavia, which is the M. pulcherrima strain, and the Initia, which is also, I think the Flavia is the type 1 I was talking about, where it generates those really nice aromas and flavors, and the Initia is used for bioprotection. And then the Biodiva is a T. delbrueckii strain used for, you can use that for the high sugar grape must, and will also keep your VA low and produce nice thiols and terpenes. And then there's Gaia, that's the M. fructicola strain that people like to use for cold soaks. These yeasts tend to be about twice the amount of money, twice as much money as Saccharomyces yeast. So I know, like, usually a brick of yeast, I'm thinking at Scott Labs, costs about $45 for Saccharomyces, and like the level 2 yeast costs like $95. I've seen some of non-sac yeast there as high as $150. So I know that that might be a little bit of something to think about if you're going to use these yeast, is the cost. But I think that the benefits in some cases might justify the cost. Another producer is C.H.R. Hansen. The common supplier for that is Gusmer Enterprises. They have a line of viniflora yeast. They have Concerto and Octave, which are both L-thermotolerants, but the Concerto is for both reds and white production, whereas the Octave is marketed for both white and rosé wines from warm regions. And then you have your Prelude, which is the delbrueckii, and your Melody, which is that Sac-Syrah VCA non-sac blend. Another producer is Lafort. I don't know how many people are familiar with Lafort. I know they don't have as big of a presence out here, but they also do produce yeast, non-sac yeast. They have Omega, which is an L-thermotolerance, Agide, which is that blend, that delbrueckii and pulcherrima blend. And then they have the Cayo, which is made specifically for whites and rosés and pulcherrima. And then Alpha, which is the delbrueckii. And that's marketed for all wines where you want to boost aromatic complexity and mouthfeel. And then another producer, which I forgot about them and I added them on, but they are also have a couple of cool non-sac products, would be Anartis. They have their Anartis firm yeast. The QMCK is the M. pulcherrima, and the Q Tau FD, like these funny codes for their yeast names, but the Q Tau FD is a freeze-dried strain of the delbrueckii. So this is an interesting strain because it can be used as a single yeast in fermentation, and it can produce up to 12% ethanol. So there's a chance that you don't have to sequentially inoculate with Saccharomyces if your sugars come in low enough from your grapes and you think you're only going to achieve 10 or 11% ethanol. You can use this QMCK to finish out your full fermentation and not have to worry about sequential inoculation. I think that, yeah, that's about it on my end. I tried to get done in less than 30 minutes so we could have some time for some Q&A. Aaron, do you want me to stop sharing?
Well, hang tight. Let me stop the recording.